Hello and welcome to R&D Mathematics. Today we are going to graph higher degree polynomial functions. Now in our previous videos we learned all the required little techniques and we are now going to put everything together. Now let's see an example. So let's say you have to graph f of x equal x to the fifth minus 4x cubed. First step is actually finding zeros. Now, the way to find zeros is actually factoring. So, f of x to the fifth minus 4x cubed, I can pull x cubed out and then I'll have x squared minus 4, and x squared minus 4 is difference between 2 squared, so x minus 2 into x plus 2. So the zeros are x equals 0, that is from this guy, and from this guy we have x equal 2, and from this we have x equal negative 2. So x equals 0, x equals 0, x equal 2, and x equal negative 2. Now let's write down actually multiplicities. So multiplicity, we explained in a previous video, is the power of that term in volume. So the 0, x equals 0, that 0 has multiplicity 3. And this one has multiplicity 1. And this one has multiplicity again 1. Now because of that, the graph, see, all of these three things are odd, right? Odd, odd, and odd. Because of that, graph actually crosses all these three places. Graph crosses x-axis, graph crosses remember we learned if it has even multiplicity it will either touch like this, it touches. If it is odd, it crosses like this. So because we have everything odd in this case, it crosses. This information is really helpful. And then intercepts, actually why intercepts? Because we already done with x-intercepts. Y-intercept, because there is only one y-intercept for a function. It cannot have more than one. Now finding zeros, this is actually x-intercept. So we are done with x-intercepts. Now for y-intercepts, what you need to do, set x equal 0. And when you set x equals 0, that means you are finding f of 0, and that value is obviously 0, because 0 to the fifth minus 4 times 0 cubed, that is 0. So the y-intercept is 0, 0. And the x-intercepts are actually these guys, x equals 0. That means actually, see, for x-intercept, y value is 0, the y height is 0. So x-intercept are 0, 0. That's from this, and from this 2, 0, and from this negative 2, 3, 0. So at this point, we know our graph, let's say negative 2, 0, somewhere here, and 0, 0, and 2, 0, 1, 2, and then here 0, 0, it's already covered here. So we know our graph crosses, see, crosses through this point. It can be like this or like this. We don't know it yet, like this or like this, like this or like this. We do not know it yet, but at last we can figure it out. Now we are almost done actually. Now what we need to do, the last step, end behavior. So end behavior. That means when x is large, see, for large x, so remember our last video we talked about this, for large x, fx behaves like, always a polynomial function for large functions, it behaves like the highest degree term, so x to the fifth. This is the power function. And remember the general definition of power function was a xn, and we had all those four cases. A can be positive or negative, and n can be odd or even. Now in this case my a is 1, because here the number 1 in front of this, and 5 is odd, so we have odd positive case. So this case is odd positive. Odd positive, again remember my last video, and also previously I explained power functions. Odd positive will have, like x cube, we know it will have this shape. When x goes to negative infinity, it's going to negative infinity, and from right side it will go up. Now with this information, this is powerful, and with all this here, now we are in a position to complete our graph. So what will happen now, guys? Look, have a look at this. I want you to focus on this green color box. This is where we are going to, you know what, let me draw it clearly again, taking some space. So let's say I'm going to do it over here, my graph. Okay, now the places negative to 0, I know my graph crosses these 3 points and 2 comma 0. So here negative 2 comma 0, here 0 0, here 2 comma 0, and I know they cross it, and I know when my x is large enough, somewhere here my graph is going to negative infinity like that, and from somewhere here it goes to positive infinity. And now it's all about, you know, little IQ, some thinking. Look at this point. Can it cross like this? It can, because if it cross like this, I will have to go somewhere here and connect it. But I know for sure my graph does not have any more x-intercepts, does not have any more zeros. So that is not the case. So the only way it can happen is it goes like this. And then from the right side, only way it has to, you know, we know it crosses, so it will cross like this. Now it's all about combining it. So it will have to make a turn, and so this is our graph. Now if you wonder what are these places, these maximum places, what are these? Well, that goes to calculus, right? There are very easy ways to find using calculus, maximum and minimum differentiation, stuff like that. For some problems using simple algebra we can determine, but at this point this is the roughly graph. This is all you need to know. Okay, let's see one more example. How about this? F of x equal x plus 2 x minus 1 squared. Now it's already been factored, which is really nice. The first step, it is not factored, you have to factor it. So let's find zeros. So zeros, again, really easy because it's been factored. Zeros and multiplicity. Now zeros, from here we have negative 2, x equal negative 2, and the other place we have x equal positive 1. And the multiplicity here 1 and here 2. Because of that, we know graph here cross x-axis, and here touches and crosses x-axis. Okay, and then the next step, y-intercept, because these are x-intercepts, zeros are x-intercept, and we know because of that x-intercepts are negative to 0, and 1 comma 0, because for x-intercepts the y value is always 0. Now y-intercept, x value is always 0, so you put f of 0, it's pretty easy, 0 plus 2 times 0 minus 1 squared, so 2 into negative 1 squared, which is 1 and 2, you get 2. So y-intercept is 0 comma 2. Now let me make a box like earlier. At this point, we know negative 2 comma 0. So right here 1 comma 0 somewhere here, and 0 comma 2 somewhere here. Our graph will go through these points. That's all we know. Now in order to finish this, we just need end behavior. End behavior. Now for large x, this is how you write it down. For large x, you have to write down these steps, then it makes sense. For large f x, okay. Now at this point we have a problem because this function is not given in the standard form, the particular way. So you will have to actually simplify this. So x plus 2, x minus 1 squared, when I expand it, x squared minus 2x plus 1. And then when I term by term multiply it, I get x cubed, and then I get negative 2x squared, and then plus x, and from this plus, you know what, let me write little bit to the right, plus 2x squared, and from this minus 4x, and from this plus 2. So when I simplify x cubed and 2x squared and 2x squared, that will cancel, and I have minus 3x plus 2. So the power function, the highest degree term we are looking for is this. So for large x, f behaves like x cubed. So axn power function, a is 1 in our case, n is 3. Again, we have like previous example, positive or odd positive. So like this from here and from here, this behavior. So odd positive, we have like this behavior. You can put it in our function now. You just have to complete it. So since, see, negative 2 comma 0, negative 2 comma 0, right here it cross, so it makes sense, it will go like this. And from here 1 comma 0, see, 1 comma 0, it touches, which makes sense because if it cross, there is no way of coming to this point 0 2 without crossing it again. So it touches and comes to 0 2 and draw it like this. Now again, let me, what if somebody draw it like this? What if somebody draw it like this? Well, what if somebody well, it's also okay, because at this point we don't know this maximum. It happened, it's a relative maximum. It happened where you need calculus to do that. Again, if we do a little bit more investigation, you know, use some problems using algebra, we can tell that. But at this point, this rough shape is enough. And let's do one more example. How about f of x equal 2x to the fourth minus 8x squared. Now first step, zeros. So zeros and multiplicity. To find zeros, I will have to factor it. I can take 2x squared out, then I will have x squared minus 8, right? And squared minus 4, I'm sorry. So this will be 2x squared, x minus 2 into x plus 2, difference between 2 squared. So from here I have a 0, x equals 0, and from here I have x equal 2, and from here I have x equal negative 2. Multiplicities are 2, 1 and 1. Because of that, graph touch. With even, it always touches x-axis, and with odd, it crosses x-axis, crosses x-axis. So zeros means x-intercept. X-intercepts are 0, 0, y value is 0, so 2, 0 and negative 2, 0. So at this point, we know our graph will 0, 0, negative 2, 0, and 2, 0. Okay, now the next step, y-intercept. That means you put x equals 0 or f of 0, which is pretty straightforward, 0. So y-intercept is 0, 0, and it happens to be an x-intercept as well. Now, finally, end behavior. For end behavior, the highest power is this. So for large x, f behaves like 2x to the fourth. So a xn, a is 2, n is 4. So positive, even positive. Even positive, if you guys can remember, see even positive things like x squared, x to the fourth, x6, so it goes to infinity from both directions. So we have this shape. Now it's all about combining. So this point, negative 2, 0. Let's see. And here 2, 0. They must cross, right? Because if we touch and turn around, well, we can say mass in this case. I mean, yeah, so negative 2, 0. See here, it crosses. We got it crosses. It's not touching. So it crosses, comes like this, it cross, and from here also we have 2, 0, see it cross, and then we have at 0, 0 it touches. Now you have to be a little bit, use your educated guess, like there are two ways to cross, either like this or like this. Which one is going to work, upward one or downward one? Yes, the downward one, because there is no way to connect the upward one without crossing the x-axis again from this guy, right? So the downward one will work. So this is the required crossing. So somehow you just need to make them connected. So some kind of shape like this. That is our graph. And I think that's enough examples for polynomial graphings. And thank you.